Hi everyone. When you're working on an abbreviated truth table, such as this problem, which is 7.4a, number 10 from your homework, the key idea is that you're going to try to find a row of the standard truth table in which the conclusion is false and all of the premises are true. Immediately, if you know that all the premises can be true and the conclusion can be false at the same time, then you know that this is not a valid argument. And that's what you're trying to prove with this abbreviated truth table. So let's take a look at this one. The problem is with the three statement variables P, Q, and R. The argument is if P, then not Q, if and only if, not R. That's the first premise. Then R is the second premise. And then the conclusion is not P. And you want to evaluate this. You want to figure out if this is a valid argument or not. So let's just start with the conclusion. We're going to mark it as false. We're going to mark the conclusion as false. Since the conclusion is not P, that means we'll mark an F under the tilde and a T under the P. And since we know that the same truth values have to go across and fit everywhere in the table, we'll say, okay, P, when I see P here in the first premise, so we'll mark it true there while we're at it. Now, what about the other two premises, or the other premises? Well, we want to make R true. That's easy. And we want to make this complicated first premise, this if P, then not Q, in parentheses, if and only if, not R. We want to make that come out true. And that's a biconditional, and we'll mark it true under the biconditional arrow, or the double arrow. We also have no part of the answer for filling out more of this. We've got R being true, that's in the second premise. So R has to be true when it's inside the first premise. And then that means also that not R is going to be false. So we got. But how do we figure out what we have to assign inside these parentheses to finish out this first premise? Well, this is a biconditional. We know that one branch of the biconditional, the not R, is false. A biconditional is false, a biconditional is true whenever both branches are true or whenever both branches are false. So if not R is false, then this if P then not Q also has to be false in order for the whole biconditional to be true. And so we'll mark that. We'll mark that there. But does that tell you what not Q should be? Indeed it does, because that's a conditional inside the parentheses. If P, then not Q. And there's only one way for a conditional with a true antecedent to end up being false, and that's for it to have a false consequent. That tells you that not Q must be false, and therefore that Q must be true. And there we have it. Take a look at this. Do you see any problems? Any values that we have missed? No problems there. Okay, let's put the values in over on the left-hand side. And we know that P has to be true, Q has to be true, and R has to be true. And if we've done this all correctly, we should be ready to say that this argument is invalid. Let's click the button. And there we are. The argument is invalid, and we've done it. Congratulate yourselves, and thank you for your time.